Hello! So today we're going to be looking at two kind of funky systems of equations questions. What's really nice about them is they're pretty different to the usual simultaneous equation sort of questions that you see in school, but they teach you some great techniques along the way. So as always, pause the video, try them yourself. So let's look at this first system of equations first. Now we have 5 equations happening simultaneously. And what you might notice is that actually there is the same amount of letters on the left-hand side of our equations. So what we can actually do is we can add them all together. Because what we end up getting is 4 lots of A plus 4 lots of B plus 4 lots of C plus 4 lots of D plus 4 lots of E. We have 4 of each letter. And all together this equals to the right-hand side all added up. 8 plus 12 is 20, plus 20 is 40, plus 16 and 24 is another 40, so that's 80. Therefore, we can factorise out that 4, another plus in there, and so we get that A plus B plus C plus D plus E equals to 20. Now, how might that help us? Well, if we look at equation 1, for example, and line them up next to each other, A plus B plus C plus D equals to 8. What we can do is we can just take away the second one from the first one. The A's, B's, C's and D's cancel out, and we're left with E equals to 20 minus 8, which is 12. Now what we're looking for is D, so all we need to do is find which equation doesn't have D in it, and that would be the second one. So we have our main equation that we found, A plus C plus D plus E, which equals to 20. And we also know that A plus B plus C plus E equals to 12. So when I subtract these from each other, I'm left with just D equaling to 8. And that's my answer, D equals to 8. And you can use the same method to find all the other letters. So that's the first one. So on to the second question. Here we have another system of equations, except this time our simultaneous equations, our variables on the left-hand side are multiplied together, not plus together. So that might give us a hint of how we want to continue. And actually in this one, x, y, and z are all going to be positive. They're going to be greater than 0. So pause the video, try this one yourself. Okay, so let's imagine you added them together because you wanted to do something. The issue is this doesn't help us at all. In the previous one, we could find more information from doing this, but in this one, we can't. So instead of adding them together, why don't we try multiplying them together? Because what we end up with, if we do xy times yz times xz, is x squared, y squared, z squared, all equal to all the right-hand side multiplied together, which is 144. And now you might see why this is helpful, because we have that xyz is equal to 144, well xyz squared is, sorry, which means that xyz is equal to the square root of 144, which in this case is 12. And we know it's positive because x, y, and z are all greater than 0. So when we times it all together, we have to get a positive answer. Now, how can we use that? Well, let's look at equation 1. We have x, y equals to 2. But we also know that x, y, z is equal to 12. Which means that if we just divide these, we get that z, because the x, y, and the xy cancel, equals to 12 divided by 2, which is 6. And that's our first variable. How about the next one? X, y, z equals to 12, but now we have that y, z equals to 24. So when I divide these, what do I get? Just x equals to a half. So for the last one, we have x, y, z equals to 12, and we have that x, z equals to 3. So when I divide these, I get that y is equal to 4. And now I have x, y, and z, I need to add them all together, and I just get 10.5. X plus y plus z. And that's my final answer. X plus y plus z is 10.5. So I hope you enjoyed trying those two. If you did anything different, please let me know in the comments below. As usual, thank you very much for watching, subscribe for more content, and I'll see you in the next one.